Hello guys. Hello. Hello. Am I audible or not? Am I audible or not? Am I audible? पानी दे देना. आवाज आ रही है भाई. आवाज आ रही है कि नहीं? Am I audible or not? I want to know. Submit. Hello. Hello. Am I audible? They will giving the reply or not? You must tell. Okay, it's fine. So we will learn prime numbers today. Okay. So basically, I learned prime number and I will try to teach that what is basically prime. Okay. So we can start with the questions. Okay. So we have given the question that, okay, uh, we have given a number and we have to tell them if that particular number is a prime or not. Okay. So how will we do this? So one of the brute force approach is that what we actually know, what we actually know about prime number. So one thing we actually know about prime number is, wait a moment. Wait. Okay. So one thing we know about prime number is that, okay, if that particular number is a prime number, it's either wrong. Oh, bhai. तो भाई आगे कंटिन्यू करते हैं। प्राइम नंबर के बारे में एक चीज तो बता दी थी कि सबसे पहले बार प्राइम नंबर क्या होता है। प्राइम नंबर वो नंबर होता है जो खुद से, ठीक है, प्राइम नंबर इज अ नंबर विच इज डिविजिबल बाय वन एंड इटसेल्फ, दैट व्हाट आई ऑलरेडी टेल यू। Okay, that is basically the prime number. So if I take any number from uh, 1 plus 1, or we can say that we can take the number from 2 to n minus 1, and if a particular number, suppose any number n, if that particular number is divisible by that number from 2 to n minus 1, it means that this is not a prime number. So that's what why I already tell you. Second thing I already tell you is that, okay, any composite number can be formed by multiplying two numbers. Okay, and that two numbers are basically the factor of that n. Fine. So if they are factor, we are analyzing one thing is that, okay, suppose if there is a composite number, and what I know that I can write it into the form of multiples of basically two numbers. Okay. So I can either write it in form of like 1 into 36, or also I can write it 2 into 18, and then 3 into 9, 3 into 12, 4 into 9, and then 6 into 6, and then after that 9 into 4, then 12 into 3, and then 18 into 2, and then after that 36 into 1. So one thing, if you observe here, is that this is basically a pivot point. Okay, this is basically a pivot point, and after this point, this value will be repeating again. If you see here, that okay, this value is repeating again. So what we are observing here is that, okay, suppose if I multiply two numbers, I got a third number. Then it and these two numbers are basically the factor, right? These two numbers are basically the factor. Now we have to decide that what are these factors. So we are considering three situations. So what we know that if I want n by multiplying two numbers, these two numbers will have three possibilities. Three possibilities. What three possibilities? First possibility is that a is greater than under root n and b is greater than under root n. So suppose if both value a and b is greater than under root n, okay, and if I multiply it, will I ever get n? No, because it will give me the value is greater than n. So this possibility is not true, that a and b both are greater than under root n. Now let's take both is less than under root n. Okay, so if we take both less than under root n, then what we are observing here is we never reaches till n. So it means that this possibility is not true. Now we will check that, okay, if a is equals to under root n and b is equals to under root n, then we get the value is equals to n. So there is one possibility, and now what we are observing here is, one thing we are observing here is this is a pivot point, and after this point the factors will be repeating. Okay, which factor is repeating? So basically, if we see, this factor is repeating here and this factor is also repeating here. It means that after pivot point, there is no new factor has been generated. So one thing we are observing here is that, okay, if we take both factors greater than under root n, then we never reaches till n, because after multiplying we get value greater than n. So it means that one thing we are observing here is that, okay, one of the factor must be less than equals to under root n if that number is a composite number. So for any composite number, we can write it into the form of multiplying two number. भाई आपका शेड्यूल क्या है, हमेशा पढ़ते रहते हो क्या? कह सकते हो, कह सकते हो। मतलब शेड्यूल ऐसा है कि यार टाइम मिलता है तो आ जाता हूँ पढ़ाने। मोस्टली मैं ट्राई करूंगा कि रात में आ जाऊँ, क्योंकि पूरे दिन तो पढ़ना ही रहता है, तो टाइम मिल नहीं पाता, और कॉलेज का प्रोजेक्ट वगैरह भी है थोड़ा। So hope so you understand that. Okay, if there is any number, okay, and basically that number is a composite number, then we can get that composite number by multiplying two numbers, and that two numbers are basically the factors of that n. And if that two numbers are basically the factors of n, then one of the factor must be less than equals to under root n. One of the factor. Okay, so it means that rather than checking till n, so basically what we are doing here is we are checking from 2 to n for a prime number, right? And we are dividing that particular number with every possibility that we get from 2 to n, n minus 1, right? But rather than doing that, what I know is that if that number that I consider, if that number is a composite number, then one of the factor must come from in the range of 2 to root n. And if that factor not come, it means that that particular number is a prime number. Okay, so rather than going till n, what we are doing here is we can go still only under root n. Fine. So we are reducing the time complexity from big of n to big O of under root n. Uh, that is the one thing. Now, so if we see that, okay, under root n. So suppose if we have given suppose if we are given 36, right? And now what we wants to do, we want to generate all the numbers. So if I want to generate all the numbers, what I will do, I will generate first all the factors which are divisible by 36 and which is less than equals to under root n. So one of the factor is 1, another factor is 2, another factor is 3, then I think so another factor is 4, then there is no 5 because 5 will never divisible divide that 36, and another factor is 6. Now if I want to know that what is the another factors, what I know that okay, if that is a composite number, I can write it in form of this. What I know is that if this number is a composite number, I can write it into the form of multiplying two numbers, and one of the number will be less than equals to under root n. So I know that okay, either A or B, one of them will be less than under root n. So this all are the factors. Now if I want to generate another factor, like suppose if I know B, I want to know A. How will I know A? So A is equals to what? N by B. So I already know that what is B. Okay, so B is 1. So what is A? So A will be 36 by 1. So another factor will be 36. 36 by 2, which is 18. 36 by 3, which is 12. 36 by 4, which is 9. And 36 by 6, which is equals to 6. So we get this two times, so we can remove it one time. Okay. So by knowing the factors till under root n, we can generate all the factors of that particular number. So this is one of the things. Now, can we optimize it further? Like we know that if I want to know if that particular number is a prime or not, I know that okay, I have to check till under root n. But will I optimize it on CPU level, not on time complexity level, but can I optimize it on CPU level? Let's try. So what I know here is that suppose if I take 70, what I will take? I will take 71. Okay. So if I take 71, if I under root it, what I will get? What I will get? So under root of 71 will is equals to, wait a moment, 8864, and okay. So I will get something around 8 point something. Okay, 8 point something. So I can consider it to be a 8, right? So if I want to check that if that particular number is a prime or not, what I will do, I will start from 2 and go till 8, and I will check. Okay. So I goes till 8 and I will check. So it means that I can divide it by 2, then I will divide it by 3, then 4, then 5, then 6, then 7, then 8. Okay. So one thing I know is if that particular number, like 71, if that particular number is not divisible by 2, then how it will divide with 4, or how it will divided with 6, or how it will divided by 8. Like if that particular number is not divisible by 2, then it is also not divisible by 4 also. It is not divisible by 6 also. It is not divisible by 8 also. Right? So what I will do that, okay, so first thing what I will do, I know that, okay, if that particular number is not divisible by 2, it means that it is also not divisible by 4, not divisible by 6, and not divisible by 8. Okay, because all of these are basically the factor. Okay, I can get that number by multiplying 2 with any number. Now, second thing. So suppose if I take 9 here and 10 here, 11 here, 12 here, 13 here, something like that. Just consider as an example. So I will cut everything that is divisible by 2. So I will cut 10 and then 12 here also. Okay. Now, one thing I know, if that particular number is not divisible by 3, then it is also not divisible by 9, right? Because if that not divisible by 3, after dividing the 71 by 3, I will not get 0. Then how will I get 0 when I divide that 71 with 9? Okay, so let's try it. So what I know, if I divide 71 with 3, what I will get? 3 to 6, and then I will get 1, and then 1, and 3, 3, and then 9, and then I got 2, and then I have to take the decimal values, right? So suppose if I take 71, 9. So 9, 9, 9, 7, 63. Okay, 63. And what I will get? I will get 8 here. Okay, and after that, if I want to add, suppose 0 here, what I know that I have to add point here, and then after that 0 and 9 or something I will get. Okay, so it means that I will get something like a decimal value. Okay, so if I get something decimal value, it means that this number is not divide that particular number. Okay, so what I understand here is, okay, if this 3 is not divided 71, then all the multiples of 3, they are also not divide that 71. It means that I have to remove everything like 12 and also all the multiples of 3. So I will remove 3, and now I will remove that 9 also, and every multiples of that, what I said, every multiples of that 3. Okay. So now I will left with 5, 7, and then another number is 11 and 13. Okay. And after that, if you see, I got number 17 and 19. So I will get something like this. Okay, I will get something like this. So now, rather than checking from 2 to 8, 2, 3, 4, 5, 6, 7, 8 from every number, now I will start from 5, and then I can check with 5 and 7 if that particular number is divisible by 5 or 7 or not. Okay, and if that particular number is either divided by 5 or 7, okay, it means that this is not a prime number. Okay, if it is not divisible, then I will check for another number. So what is that another number? So that another number will be 11 and 30. Now, if you analyze carefully, this is what? This is what? This is basically 6 into 1 minus 1. And this is what? This is 6 into 1 plus 1. Now, this is what? This is 6 into 2 minus 1. This is what? 6 into 2 plus 1. This is 6 into 3 minus 1. This is what 6 into 3 plus 1. Now, if you see carefully that rather than checking from 2, 3, 4, 5, 6, 7, 8, 9, okay, so how many times I have to check? I have to check one time, two times, 3, 4, 5, 6, 7, 8, or basically 7. Okay, I have to check it 7 times. Now, I have to check only 2 times. So I will reduce the time, or I will reduce basically the CPU work by 1 by 3, right? 1 by 3. So if you see that I will not reduce the complexity of checking the prime number, which will be under root n, but I will reduce the CPU, basically CPU work, right? So rather than checking for every number from 2 to under root n, I will check only for, I will start checking from 5, and then I will take the jump of 6 only. And what I will do, I will check that number, okay, if that number is divisible by I, or if that number is divisible by I plus 2. If that particular number is divisible by any of this, then it means that this is not a prime number, right? So now, basically this will reduce the work by 1 by 3. Okay, and now let's check that how we can, what is the basically code of this. Okay, so let's write it. Okay, so what I know, I have to check that if particular number is a prime or not. Okay, so mm, one prime. Okay, hashtag include uh fit slash std plus plus dot h, and that using namespace space std uh, int main. Okay, and then return 0. And then what I will do, I will call the function that I will create. Okay, and what is that function? That function will be void call. And what this function will do is that, okay, it will take the input c in n. Now, one thing I will know that if a number n is less than equals to 1, so if that number is less than equals to 1, it means that this is not a prime number. So I will print cout no. Okay, cout no and then, and I will return it from it. Now, what I know, I have to check that if that particular number is divisible by 2, or if that particular number is divisible by 3. Okay, then also I have to write same thing, that okay, if that number is not divisible. Okay, and what I also know is if n is less than equals to 3 here, so it means that this is a prime number. Okay, so if this is smaller than 1, or either it is equals to 0 or 1, it means that this is a not prime. If it is either equals to 2 or 3, it means that that number is a prime. And if that particular number is divisible by 2 or 3, it means that they are not prime. So I will write here this is a prime number. Yes, and I will return. And after that, what I will do, I will check that if that particular number is a prime or not. So how will I check? Oh, wait a moment. For int I is equals to 5, I is less than, not I is less than, I into I is less than equals to n, and I will take the jump of 6. Okay, and after that, what I will check? I will check that, okay, if n modulus I is equals to 0, or n modulus I plus 2, I plus 2. Mm, wait a moment. Let me check. I plus 2 is equals to 0, any of this. So I will return that, okay, this is not a prime number. No. Oh, I will return. Oh, bro, yeah, buddy, welcome, welcome. Otherwise, I will return it, okay, this number is a prime. See out. Yes, I think so. This should work. Mm, yeah, this is accepted. How did someone solve code forces topic? Why? I'm a noob in code forces. No, basically, I am just picking up the topic, read that topic, understand that topic, and just ask GPT or Gemini to give me some questions, and I will try to solve that questions. Not jump to any of the question like I will do this question or this question. Uh, don't know where to start. So, if you want to start, first you have to know the basic DSA portion, that how to initialize the array, how to initialize string, how to use string, what is for loop, what is if else. And if you know it, and what is classes, then it's more than enough. Then you have to know the little bit DSA portion, or if you don't know the DSA portion, then also it's okay. You can try the 800 rating problems. They are not using that much data structure portion. So you can solve that questions. How you topic wise question? How you find topic wise question? So basically, I will ask from the Gemini or GPT that, okay, I want to study that uh, competitive programming and give me what all are the topics that I want to know. So they will give me that, okay, you have to study that topic. So I will study that topic, and after studying it, I will ask for the question that give me two or three questions. I will try it. And after that, after trying, if I am not able to solve, I will ask for the solution or the hint. And this is how actually it works. And if you want to improve more, then you have to give the contest. So that's it. In a day, how much practice for DSA and how you do that? So I will do DSA 6 to 7 hours, like only 6 to 7 hours. And most of the time, I will give to the development and the learning portion. I got to point where I can't implement a code, but I can understand the logic. So it's fine. It's fine. If you're not able to write the code, then then what you will do is that read the code. That okay, so basically what is the problem that you understand the logic and you don't know how to write. So then ask from the AI. Ask from the AI that I know this logic, I want to implement that logic, and now what is the code of this? And understand the code that okay, I was thinking like that, and now how I will implement it. And it will take time, but you will get improved in this. So this is the only way. So another question related to Prime is that uh, this question. Okay, so what I have to do here is that I want to, okay, guys, so this is the code of checking that if particular number is a prime or not. Okay, and now what we have to do here is that we have given a number and we have to print that, okay, this all are the primes. Okay, I have to print it. So what I will do here is, yeah, bro. So basically, I'm watching too much of solutions, but not coming up to approach by myself. Uh, are you watching the solutions or are you able to think that okay, in this question I have to do this, but you are not able to code only that how I will write the code of this. That you understand the logic, you will dry run it, that the solution has been implemented, and now you don't understand how to code it. So if you don't know how to code it, भाई रेटिंग कितनी है? अरे रेटिंग नहीं है। रेटिंग उसकी होती है जो ज्यादा इस चीज पे ध्यान देता है। मैं डेवलपमेंट और मशीन लर्निंग पे ज्यादा ध्यान देता हूँ, तो इसमें मेरी रेटिंग नहीं है। बट इफ यू गिव मी 6 months, देन आई विल शो यू। आई वांट 6 months because I am new in that, and mostly my way of learning is that teaching. That if I want to learn something, then I must have to teach. Then I can easily understand, because I can understand, but if I am not able to explain, it means that I don't know that particular topic. So that's why I am teaching that whatever I have learned. Currently, I am doing अपना college DSA with Java course not completed yet, but I am not doing practice, just completing the course only. Don't do that, buddy. Don't do that. Because in the end, if you know some topics, you have to know it in depth. Then only you can implement it. Uh, ML में यार अभी तो रिग्रेशन ही चल रहा है। पढ़ ही रहा हूँ। Okay, so one thing I understand here is so wait a moment. I will open the VS Code. I will paste the code there. Prime number of CPP. Okay, I can say there is some prime number of CPP. Yeah. So, oh. Wait a moment. So, so I have already tell you about that. Okay, this is basically the code of a prime number, that rather than checking for every number from 2 to under root n, we will only check for if that particular number is divisible by this or not. And one thing we also have to add here is that if I have to add it here, that I have to add 2 lines. Okay, so I think so. I have to remove this, and I have to paste this, and then also I have to remove this here. Okay, what is this name? This name is call better. Call better. Uh, remove this. Okay. Okay, fine. What's the problem? Okay, so I have to return. I don't have to return anything, right? I have to remove this. Or also I can return, like if I want, I can return it like this. Bool, and then this one is what? Leave it. Okay, leave it. So, okay, in this question, it is given that what we have to do here is that I want to print the, basically we have given a number, like suppose, mm, wait a minute. So, it's silent. So we have given number 8, and now it is given in the question that print all the prime numbers till 8. Or if I take 10, I have to print all the prime numbers till 10. So what all are the prime numbers? So 2 is prime number, 3 is there, 5 is there, 7 is there. So I want to print that numbers. Okay. So one of the approaches that what I actually do here is that, okay, I will take that number. Okay. So I will show you the code that what I was thinking. So, primes. And in this, what I have to do, I have given a number C in N. Okay, C in N. And now what I have to do, I have to start it from 1 and goes till N. And now I have to print all the prime number. भाई लास्ट ईयर में हूँ इसीलिए ऐसा लग रहा है कि किसी के लिए टाइम ही नहीं बचा। डीएसए बाकी है, एप्टीट्यूड बाकी है, वन स्टेप पूरा नहीं आता। सो आई एम जस्ट ऑफ कैंपस जॉब लेना है तो मुझे व्हाट ऑफ कैंपस if you want to achieve anything, understand it that it take time, and it take time of 6 to 7 months. You don't have to do everything. You have to first select that where you have to go. Like, one thing you have to understand is that at this point, you or me or any of the tier 3 student who are in fourth year and who are not doing anything are not able to crack that Amazon or Google or something. So think realistically that, okay, what is the possible scenario that where I will goes in next 6 months. So it is mostly service based company. So what they are demanding, just learn that, and after getting a first job, then you have to improve, and after improving, then you can switch to any of the company. Think realistic. Don't think too much that you have to do this, because it will literally frustrate you and you will not do anything. If you see the service based company, they are mostly asked DSA questions. So just focus on DSA. Don't think about competitive programming stuff too much. Okay. And after that, participate in hackathons or anything, or create some projects in development. Because basically, if you are learn machine learning from now, maybe it will take more than 10 months because it is too vast. So that's why I would suggest that do DSA, do development, and just uh, join any company for approx 1 year and try to grind it there, and then you can switch uh, from wherever you want to switch, right? So this is one of the way that you can follow. So one thing I understand is that, okay, I have to check if that particular number is a prime or not. What I will do, I will check it by call better. Inside that call better, I will pass that, okay, I will pass this I, and okay. So one thing what I will do here is that I will create, and I will change the name of this. What I will do, I will change the name of this is prime. Okay, and inside this, I will pass int n. Now remove this, and I am checking for n. And if this is less than n, I have to return false. Now, second thing, I have to return true here, and also I have to return false here. Also, I have to return false here. Okay, also I have to return false here. No, not false, because this number is prime. So I will pass this inside is prime, and this is prime will tell me that, okay, this number is a prime or no. If that number is prime, then what I have to do here is that I have to print C out I. Okay, this is basically a prime. Okay, and I have to give this space. सर्विस बेस्ड कंपनी में कैसा डीएसए क्वेश्चंस पूछते हैं और कॉम्पिटिटिव डीएसए में क्या फर्क है? So competitive programming DSA is mostly related to logical thinking. Okay, some of the questions or most of the question you see in competitive programming, they are mostly maths, too much maths. But if you see the data structure problem or lead code problem, there are some questions, or there are too many questions which only require the pattern recognition. That okay, I have seen that okay, I have to apply two pointer here, I have to apply sliding window here. So if you see the service-based companies, they are mostly asked that type of question. Now, if you see the product-based companies, if you see the overround of that particular companies, they are mostly asked that competitive programming or too much maths question. So this is the difference. Now, if you ask what is easier, pattern recognition is much easier than logical thinking. That you have to think too much, because in some question you are thinking too much and you don't have to think that much on that particular question. This is also a complex thing. Like, have to do this or not. First, we have to think that will I think it or not. Sure. I will show you that if you come for 2 or 3 days, I will show you that what is the difference between a competitive programming question or a DSA or pattern recognition question. Okay, so what I've seen here is that what I am doing here, that okay, I have given n and I have to print all the prime numbers. So if I want to print all the prime numbers, so simply what I will do here is that what I will do, I have to check primes is prime. And this is basically the function. Okay, and now what I will do, I will copy this. I will copy this and okay. So there is a submit code. I will paste it here. What is this? Primes. I will paste it, and now I have to create a main function here into main. Okay, into main, and inside that I will return 0, and then also what I have to do here is that primes primes. Okay, I will call this, and I have to include two things. That has to include bits slash std c++ dot h, and second thing I have to include here is uh, name is space dot std. That's that. Mm, Now, if you see here that this is accepted, but will this be a optimal approach? No, because if you see here that this loop, actually this loop, what this loop will do? This loop will run n times. Okay. And what is this? This is function. But if you see in this function, this loop will run under root n times. So the total time complexity of this code will be n root n into root n, right? So basically, this is the complexity of this. So will we optimize it? Will we optimize it or not? Yeah, we can. We can optimize it into n log n. So basically, if you remove this and if you remove this n, we will see that okay, root n is much greater than log n. So how will we optimize it, or what is this? So let's observe. Let's observe it. Okay. So what I know here is that okay, I have to create or I have to print all the prime numbers from 1 to 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So what one thing we know about prime number? One thing we are knowing about prime number is that that particular number is only divisible by 1 or itself. Okay. And one thing I also know is that 1 is not a prime number. Okay. So initially what we will do, initially we are thinking that, okay, every number is a prime number. Okay. So I will tell that, okay, 1 is also prime number, 2 is also prime, 3 is also prime, 4 is also prime, 5 is also prime, 6 is also, 7 is also, 8 is also, 9 is also, 10 is also, right? Now, what one thing we know? So one thing we know is that 1 is not a prime. Okay, so we will mark that. Okay, 1 is not a prime number. Fine. Now, second thing, second thing we know is that okay, 2 is a prime number. Okay, so if we say that okay, 2 is a prime number, then it means that every number that is divisible by 2 will never become prime, right? So any number which is divisible by 2 will never become prime. So it means that if that 2 is a prime number, then what all are the divisors? Or all the numbers that is divisible by 2 will never become prime number. It means that 4 is not become prime ever. 6 will never become prime ever. 8 will never become prime ever. Now 10 will never become prime ever. Okay. Now again, what we will do, we will jump to 3. Now, what I know that, okay, 3 is prime. 3 is prime, so I will mark that, okay, 3 is prime number. Now, every number that is divisible by 3 will never become prime because 3 will divide that number. And what I know, if that number is a prime number, it will never divisible by any of the numbers. Okay, so if 3 divides the number, any of the, basically, if 3 divides any of the number, it means that that particular number is not the prime number. So so what I will do, I will see that, okay, which all are the numbers that is divisible by 3. So I will see that, okay, 3 divides 6. So I already mark it that, okay, 3, 6 is not prime. I will mark it. So I will see that, okay, 3 divides 9 also. So I will see that, okay, I will tell that 9 is a prime, but I will see that, okay, 3 divides 9. So it means that 9 is not a prime number, okay? So I will mark it as false. Now, what I will see that, okay, I will jump to 4. I will see that, okay, 4 is already a non-prime. So I will jump to 5. I will see that, okay, 5 is prime number and all the factors of 5 is not a prime number. So all the number that is divisible by 5 will never become prime. So the 10 will never become prime, which is already marked that, okay, this is not a prime number, right? So I will mark it that, okay, this is not a prime number. So I know that 6 is not a prime number. भाई मैट्रिक्स स्पाइरल वाला कर रहा हूँ कुछ बता दे 1 घंटे से सोच रहा हूँ कुछ नहीं बन रहा अप्रोच कैसे स्पाइरल मैट्रिक्स ओके सो वेट अ मोमेंट बताता हूँ so I will see that okay 7 is there and I know that 7 is a prime number so all the number that is divisible by 7 will never become prime so this is prime and all the number like 14 will never become a prime. Okay, so I will mark this as false. If there is a 14, there is no 14. So if I see this table, the true is 2, the true is 3, the true is 5, and another true is 7. So what I know is from 1 to 10, what all numbers are prime. So basically 2, 3, 5, 7, we got this. Okay, now we will see that how actually we will get it. So मैं बताता हूँ भाई how you have to think about this spiral matrix. So basically, if this is a matrix, okay, and you have given a number, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so first you have to print this, and then you have to print this, and then you have to print this, and then you have to print this basically, and then this, and then this, something like that. Okay, something like that you have to print, right? So what you will do, you will take one pointer here and tell that pointer to be a top, and take one pointer here and tell that pointer to be a bottom. After that, take one pointer here, tell that pointer to be a left, and take one pointer here, tell that pointer to be a right. Okay, what are you thinking about AI/ML jobs in India? Is there fresher have jobs? No. So if you are trying in startup, they may take you in AI/ML role. But if you are talking about top MNCs or big MNC, they will never take you because AI/ML is a research field and too much money has been spent by the companies. So they will never allow the fresher to do anything with that product. Okay. So mostly they will hire the PhDs or MTech student or the student which are basically in the research field because this AI/ML is a research field. So if I see here that okay, what I have to do when I am here, I have to print from left to right. And so when top is here, what I have to do, I have to print from left to right. Okay. And then what I have to do, uh, then I have to do something. Then what I have to do? Okay. First, I will print from left to right. I will mark this all the pointers. I will print from this to this point, and after that, I will start from this point and go till this point, and then from this point to this point, I will tell the idea. Then what you have to do? You have to take the four pointers, and then you have to decide that how will I increment the pointer? Like first, I will start printing from 1 to 4, and then what I have to do, I have to start printing from 8 to 16. So which pointer I have to move so that I can start printing from 8 to 16. So I have to move that right pointer. So after printing from left to right, what I have to do, I have to uh, step down top uh, one point downward. And then after printing from 8 to 16, what I have to do? I have to print from this 10 to what? 10 to 13. So it means that I have to move my right pointer because I want to print from right to left. Fine. So you understand it how actually you have to approach it. Mm, so let's try it again. So one thing we are understanding here is that we already know about primes. Okay, 5 and 7. Flashy domain, software engineer is a safe option. If you are really good in software engineering, then software engineering is a safest option. Good means you know all the internal aspects of that particular thing. Like you have to know operating system, you have to know computer networks, you have to know databases in there, that how actually this databases has been implemented, how this particular language will work. What happen if I want to change something into language? Like there is a JavaScript. Inside that JavaScript, there is a function called set timeout. If you see, if you give the so basically set timeout will take two functions, not two functions, one function, callback function, and second one is the time. So if you give 0 on the timer, then it will take 1 second to implement. So how and why it will take 1 second to implement? Because I've given 0, so it has to be executed in just 0 millisecond, but it will take 1 second. Why? Because if you see the Node.js actual repo, inside it, it has been given that either you will given 0 or you will give 1. It will by default take 1 second to implement that set timeout. So you have to know this. Will Node.js, if you see that what is Node.js, you know Node.js, or you know that Node.js is a interpreted, or JavaScript is a what? What we say that compiled language or interpreted language. So basically, JavaScript not an interpreted language. JavaScript is a hybrid language. It is interpreted also, compiled also. And who will give this power? So Node.js will give this power. What is Node.js? Node.js is a software. So you have to know all of this. If you write only the code and you don't know internally how this works, will you know that if you implement that any programming language stuff, how it has been implemented? Like if you see that JavaScript, I will write the Node.js code. Suppose if I write Node.js code in a JavaScript, and then I will write node and main.js, and I will run the file. How it will pass? So there is a parser. What it will do? It will basically tokenize the code and then convert it into abstract syntax tree. Will you know it? If someone asks, what is the compiler used by the Node.js? Basically, ignition compiler. You know about it? So you have to know all of this. If you know internals, if you know everything in depth, then you can talk in interview. If you don't know anything, how will you talk about anything? So they will automatically reject you. Where did you learn CPP from? I will learn it from GPT, or I will learn it from book. Like there is a book called I have to see the name. I have books on CPP and Golang and Java, all of this. Brother, are you BTech student? Yeah, buddy. I am a BTech student. The problem with fresher is that they know basic things, and industry don't need basic thing now. They want that type of people who know one thing, but in very much depth. If you know anything in very much depth, they will hire you. If you provide anything, then they will hire you. If you are not able to provide, or if you join the company and company have to teach you something, then they will never hire you. Simple thing. Hmm. So okay, one thing I understand is okay, these are basically the prime numbers. Okay. Now what I have to do here is that okay, I have to observe two or three things more. So what I see here is that okay, I know that if I see two is prime number, I will remove all the numbers which is divisible by which laptop are you using? Victus, Victus 16. Okay, so I know that okay, I have to remove all the numbers like 4 or 6 or 8 or 10 because 2 divides all of them. Okay, so what I know is that till what? Till what? Till 8 and till 10, and after that 12, 14, 16, 18, everyone is divisible by 2. Okay, so I will remove everything. Now if I see that okay, I have to remove every number which is divisible by 3. So I will jump to 6, and one thing I understand is that okay, 6 has been cut by 2, and now I will start it from 10. Now another prime number is 5. Now if you see here, suppose if I add extra numbers like 11 or 12, 13, 14, everything, or 15, 16, okay, and 17, 18, 19, 20, 21, 22, 23, and 24, and 25 there, right? Now, what I know that this 12, 14, and then after that there is 16, 18, 18, 20, and this 22, 24, everything will be divisible by 2, so 2 will cut all of this. Now, 21 is cutted by 3, and what? Uh, 23, and what I know is 13 is a prime number, 15 is not a prime number. Basically, 15 is written by 3. Uh, Brother, in your opinion, doing BSCA is good? Yeah, it is. If you are capable enough to learn anything by your own, then it is good. Because you have to learn something in depth. Mobile का charger. Okay, so one thing that I understand here is that okay, for 2 I have to start it from 4. That it means that I will put my first cut on 4. For 3, I know that I have to jump to 6, but 6 is already cutted by 2. So I will start it from 9, right? I will start it from 9. For 5, I know that I have to goes to 10. But when I jump to 10, I will see that okay, 2 will already cut the 10. Now what I will do, I will jump to 15. So 15 has been cutted by 3. Now after that, I will jump to 20. I will see that okay, this has been cutted by 2, right? And now I will jump to 25. So I will see that okay, I have to, so basically I have to cut this 25. So it means that 5 is a prime number. And first number that I will cut will be 25, right? Will be 25. So what I've seen here is for 2, I will start cutting the number from 4. For 3, I will start cutting number from 9. For 4, I will not 4. For 5, I will start cutting the number from 25. So it means that for every I will start cutting the number from I into I. Right. So that's what I understand here is. So okay. So let's try to code it. So basically, whatever I teach you, this is called the sieve of eratosthenes. ऐसे करके कुछ नाम होता है ire पता नहीं leave it sieve of what sieve of eratosthenes. Yeah. So basically, this is sieve of eratosthenes. So whatever I teach till now. So if you want to know the prime number from in a particular range, like from 1 to some values like 2 raised to power 5 or all the prime numbers, then you can find those prime numbers in n log n time. So basically, how this complexity will come? It will become through a AGP series, arithmetic geometric series. Okay, or also harmonic series has been used. So you don't have to know about this. Just know that, okay, the complexity will be this. You can calculate it by your own if you want. It will require little bit of sequence series concept. So if you know AGP and the HP, then you must try that how this complexity has been calculated. So let's try to code this. Mm. Okay, so void sieve, sieve, what I call sieve of Erato. Eratosthenes. Okay, so how will we calculate it? So we will create a, suppose we have given n and I want to know I want to know all the prime factors in an n range. So what I will do, I will create a vector int nums or is prime. Okay, and what I will do, I will create it of size of n plus 1 and initially every number or every one is a prime. Okay, so basically this is a Boolean array. So I will write that this is a Boolean array. And now what I know that 0 is not a prime number. So I will mark this as false. So 1 is not a prime number. Okay. So 1 is not a prime number and 0 is also not a prime number. So I will write that, okay, is prime is prime 1 and is prime 0. Both are false because 0 and 1 are not prime numbers. Now after that, what I will do, I will start this. I will start it from which point? I will start it from 2. Okay, and goes till which point? Goes till under root n. Okay, why I will go till under root n? So if you see here that, okay, if I found a 2, I will start marking all of the factors from 4. Okay, if I get 3, I will start marking from 9. I will get 5, I will start marking from 25. Now suppose, so basically this is outer loop, this is outer loop, and this is inner loop. Now suppose if this is outer loop, if I get till n, what is inner loop then? Then inner loop will get till n square. So will I ever get n square element? No, because the last element will be n. Okay, last element will be n. So if I want to only go till n, it means that the outer loop will never go till n. It will always go till under root n. Then only I can reach till n inside another loop or inner loop. So that's why I have to only go till under root n on outer loop. And then what I have to do here is that I will check if is prime, if the number that I got, if this is a prime number, then okay, every number I into I till n, I will mark this as not a prime number. So how will I mark this? So if I want to mark, I will take a jump of p because for 2, I have to remove all the factors of 2. So I have to write I here. I have to take a jump of I, and then what I will do is prime j is equals to false. Now, this will give me all the prime numbers for a particular range. And now what I have to do, uh, I have to print. So int, and what I will write is prime dot size. Okay, and now I will check if what I will check if is prime I. If that particular number is a prime number, see out I. Okay, see out I. That's it. So let's try to execute it. So where is that question? Where is that question? Okay, I will take the input to be a 10, right? So I will take 10 here and I will just copy this. Okay, I have to call this also now. I have to remove this. I have to remove this and I have to write C of Elastos. Uh, what? What it has been written? Return boom. Oh, I have to comment everything. What the hell? Mm. Oh, basically this will give me 10 also. How 10 is prime, right? Oh, I've done something wrong. Basically, I have to create this of n size. Yeah, this has been passed. But uh, one thing you have to understand here is that okay, for a 10, I know that 10 is not a prime number. So why this will give me that 10 is a prime number? Why? Okay, I will go still 9 or I will go still 10. Okay, and it will never reaches till 10. I think so. Okay, 10. Under root of 10 will give me 3 or something around 3. So for 2, every factor that is divisible or every number that is divisible by 2 has been crossed out, right? So I have to go till n. Then only I will never get this. Yeah. So I will get every number. And one thing I have to also do here is that I have to tell that, okay, if mm, what I know that if n is equals to 1 or n is less than equals to 1, what I have to do? I don't have to do anything. I simply do nothing. Or, okay, it has been given in the question that n must be greater than or equals to 2. Okay. So it means that I will get this. Let's try to execute this. I think so this will work. So I will work. What compilation error? What is the error? Cin not declared. Why Cin is Cin not declared? What's the issue? What's the issue? Vector is prime. Huh? Cin was not declared in the scope. I think so. It has been declared in the scope, no? Why it hasn't? What's the issue? If the program has been run, so include bit slash uh, C in N. Let's try to execute it one more time. Yeah, it has been executed. Why? Why this has not been accepted? Submit code. Choose problem. One prime, not one prime. Prime from. Oh, it has been accepted. It has been accepted. C of C of Eratosthenes of Codeforces. Is there any question with this? No, there is no question with this. But this is the thing. This is the thing. So I already teach you about sieve of Eratosthenes, and let's try one question. So there is a question called count primes. Count primes on LeetCode. So what we have given here is that we have given a number and we have to tell that how many prime numbers are there in this range. So one thing what we can do is that we will start from 2 and go still, or we can start it from 1 and we can go still what? Go still 10. Okay, go still 10 and then check if that number is a prime or not. If that particular number is a prime, then I will increase the count. So if we see that what is the time complexity of that code, so every time if we are checking that if that number is a prime or not, it will take under root of n time. Okay. एंड भाई ये बता कि ये स्पाइरल वाला फर्स्ट टाइम कितना डूएबल है मोस्टली लोगों के लिए एंजल इट्स पिसिंग मी ऑफ गेट एनी सॉल्यूशन या इट्स ट्रिकी इट्स लिटिल बिट ट्रिकी बेसिकली यू हैव टू सी दैट व्हाट वी हैव टू डू मतलब अगर तुम देखोगे उसकी एक्सेप्टेंस रेट स्पाइरल मैट्रिक्स राइट so the acceptance rate will be 57%. Means if 100 people will see that question, then 57 people will do that question, and 43 people will not do that or not able to reach till solution. So yeah, it is okay if you are not able to understand that how you think. It's fine. So this is basically the brute force approach, and it will take n root n time complexity. So this is a problem, right? Because n root n time complexity will be much. So we can think about that sieve of Eratosthenes. Okay, we can think about it, and what we will do in this question, we have to only calculate that. We have to only calculate that if that number is prime or not, right? Hmm. So as we only have to calculate it, what I will do, whatever the code that has been written, I will just copy this code and paste it there and and try to see that if this code work or not. So I will create a one function void call, or I can either name it as int call. Okay, and inside that I will paste my code. So if that number is prime, what I will do, I will create a count variable. I will write 0 here, and if that number is prime, I will write count plus plus, and simply one thing what I will do is return the return count. And what I will do, I will return here what? Return here, return here call. Okay, and in this call, I will pass n. So rather than taking n from here, I will write n here. Now let's see if this solution is little bit accepted or not. So basically, what is n? Where it has been asked here that, okay, what is n? So if I see that, okay, if n is basically less than equals to 2, I have to return 0. Okay, because it is what it has been given in the question is that we have to return the number of primes which are strictly less than n. So if they are asked for 2, so I know that if they are asked for 2, I know that there is no prime which is less than 2. If I consider the n is equals to 2, then there is no prime. which are strictly less than n. Okay, so I have to return 0, right? So let's try this solution. Will this solution is accepted? Yeah. So will this solution is fully accepted? I will get the wrong answer. So why will I get the wrong answer? For n is equals to 3. For n is equals to 3. Okay, I got 2. So for that, first I have to understand that what basically this has been printed. Okay, something went wrong. Let's see. So for int, just remove this. I will open this in full screen. Mm, Now let's see. What is the problem? What the hell? Where is that? Where is that question? What the wrong answer? Where is that wrong answer? Okay, I will first print that what is basically the numbers that I got, C out X. Okay, okay, this has been accepted. I will get wrong answer for 3 because what I know here is that I will write prime dot size. Okay, I will write prime dot size. What I have to, I will already created prime dot size -1. If I add that case or if I submit it, oh, its time limit exceeded. And if I remove this, then if I remove this, then what? Then also the time limit has been exceeded for this much larger value. Now, what is the time complexity of this? So what I know, the time complexity of this will be n log n. And this is the optimal approach. Okay. But we have to change something and we have to think about more things. So what this will do? If you see this loop, what actually this loop will do? So this loop will start from 2. Okay. And now what it will do? It will tell that, okay, 2 is prime and every number after that, like 4 or 6 or 8 or 10 will not be a prime. So I will mark that number to be not a prime, right? So one thing I understand here. Second thing I understand here is that, okay, if I already mark that 4 is not a prime number, why will I check it? Or why will I go there? Like if you see, I have to go still which point? I have to go still under root n. So it means that af- after marking that 4 is not a prime, I am again checking that okay 4 is prime or not. So it means that this is the waste of time because what I know here is that suppose if I want to check till 100, okay, I have to check till 100, so I will get to 110. After getting 2, I will mark every number which is divisible by 2 to be a non-prime number. So there are total 50 numbers which are divisible by 2 from 100 till 100, right? So I am checking for that number also if that number is prime or not. So it means that for 4, for 6, 8, 10, 12, 14, every number, I will go there and check that, okay, you are prime or not, you are prime or not. I am asking again and again. So it means that this will basically waste the time of CPU. because CPU already know that they are not prime. But they have to check because I have to run the loop till under root n, right? So what I will do, I know that okay, every even number after 2 is not a prime number. One thing I understand that okay, every even number after 2 is not a prime number. So if that is not a prime number, I don't have to check that number. Okay, so for that we have to understand one basic concept is that suppose if I take 2 and add 2 into it, I get 4. So even plus even will give me even. Don't traverse again, counting prime, just do it in first loop. Okay, now another thing what I know is that 2 plus 3 will give me 5. So what I know is that even plus odd will give me odd. So as I know that okay, every even number is not a prime number. Okay, after 2. So what I will do, I will directly jump to the odd number. So how will I directly jump to odd number? So if you see the loop here, what I will do, I will write that j is equals to j plus I. So it will take a jump of suppose 1, 1, 1 or 2, 2, 2 or 3, 3, 3. So rather than writing this, what I will write that, okay, I will get I to be an even, or I to be a odd, I will mark this to be a 2, or I will multiply this with the 2. So basically it will always convert it into even number. And this is basically odd number. So if I add this both, I will always jump to next odd number only. Okay, so I know that j is odd number. So as I know that okay, always the j is odd because I know that okay, even number are not a prime number. Okay, so I will tell that okay, j will always be odd, and what I know that I will maybe sometime even. So or sometime odd. So if it sometime become odd, what I will do, I will multiply it with the 2. After multiplying with the 2, it will become even. And if I add odd into it will always give me the next odd number because I only have to mark all the odd number that they are not basically the prime. Okay, so I will do little bit change that okay, I will start it from 3. Okay, I will start it from 3 and I will take a jump of plus 2. After taking a jump of plus 2, what I also write here is j is equals to j plus I into 2. I into 2. That's what I will do. And will I have to change anything else? Yeah. If this, as I already write here, that okay, if I got 2, because if value is less than 2 or equals to 2, then I will return 0. But if I get value greater than 2, then I have to increase count to 1. Previously, because I know that okay, 2 is a prime number, I have to add that number. And after that, what I will do here is that I simply take a jump of plus 2 here, and I will mark this. Let's see if this will work or not. Oh, int count. Okay. I have to remove this. Uh, I got something wrong. Wait a moment. I have to remove this. Will this work? No. I have to check what's going wrong. I'm thinking in right direction, but something went wrong. Hmm, will this be less? No, no, no. What is the output? First, I have to see that what what is basically the outputs, why I get this. So for int x or what we call is prime. Okay, see out x of that's part you change already up to. You're traversing again for counting part. That's the problem. For counting part. So basically, I will remove this and I will count here, right? I will count it here. If I see that, okay, this number is a prime number, I will increase the count and after that I will uh, traverse over this loop rather than doing this, right? That's what I will do. Okay, okay, I will. I will remove this counting and int count and will do I plus plus j is equals to j plus I, j plus I, and I will increase the count here, plus plus, and that's it. And return, return count using Gaussian method. Gaussian, what's that? Ah, oh, for less than two. Okay, expected value four. Ah, same problem. Test case of 352. Yeah. Wait a moment. I've done something wrong. Why it is giving me two for int x, int x is prime. क्या लिखा है? Is prime. See out. What I got? I got this. So for 10, I got this 4. But when I'm counting, I will see, okay, if this is a prime, every number, no, not for every number. When I see that, okay, if this number is a prime number, oh, what the hell? Where is the non-prime means subtracted from A. No, I already attempt this question. But there is little. Actually, it will give me every prime number. Okay, this is fine. It will give me 4 prime, and the expected value is also 4. Here, the expected value should be 1, and for 3, so for 3, the major problem is that this loop will goes only till under root n, and it will never traverse over an edge. Will never traverse over an edge. So that's the problem. Yeah, that's the problem. So I have to traverse over n if I want to know that okay if this is a prime. Bro, hi bro, LLD and HLD के लिए कौन सा अच्छा कोर्स है या ब्लॉग बताओ ना. For LLD you can follow older armies for LLD, or for HLD you can follow Scalar Academy. You can find the YouTube on you can find the lectures on YouTube of the HLD LLD. So yeah, that's the problem. I will not count it here. This is the problem. So I will write uh, that logic that okay, I will take the jump of 2 and I have to multiply it with a 2, right? I have to multiply it with a 2 and I will calculate everything. After calculating, what I will do here is that I will increase the count plus plus. Okay, and or not count plus plus. When I encounter that, okay, if I see that for loop for int I is equals to 0 till I is less than is prime dot size. Okay, and I plus equals to 2. And if I see that okay is prime what is prime what is prime what if that I is basically a prime number, then I will increase the count. Okay, and I will return the count here. Oh, prime dot size. I will get a jump of 2. And wait a moment, guys. I will try to implement this. I will see out X. X. What this will give me. Hmm. For 10, I got 0, 1, 1, and then this. How this will be prime? 0, 1. Yeah, I have to start it from 3 now. For all of this, what the hell? But everything I got the correct value. What for this I got the wrong value. J plus I into 2, because what I know that I have to jump to next odd number. So if I want to jump to next odd number, what I know, I have to add, if I get odd, or every time I got odd only, every time I got odd only, I have to add up. Will it to Ah, 2 into I. We'll have to do this. Yeah. For this, I got the wrong answer. Basically, I have to take. Oh, J plus equals to I. So from this point, I have to start, right? If I is print, then table of I is complete. But if we count, it's wrong. 2, 3, and this is 0, 1, 2, 3. 4 is not a prime number. Why I got 4 is to be a prime number? I have to start it from this point and I'll multiply it with this. And I got 4 here. How will I have to take array size -1? Because I don't have to take n. So if I don't have to take n, I don't have to take n here. Why I got all of this to be a prime? Like 2 is prime, 3 is prime, fine. But 4 is not a prime number. Why this is marked that okay, 4 is also a prime number? Uh, if the I is prime, then the table of I is composite number. You have to count the prime and subtract it from n. As you count, as you cannot them all prime, but you can cover all non-prime. So wait a moment. Let me think. Let me think. This 2 I is equals to 2. And also something went wrong. So this is what? This is basically a 2 and 3, 5, and this is 7, and this is 9. How 9 will be a basically what prime number? 9 is not a prime number, and J is equals to I into I. And 2 in I've already write it, right? Wait a moment. J plus I is equals to 2 into J. 2 into J. J is equals, oh yeah, 2 into J or 2 into I? Like 2 into I, na? 2 into I. But I have to add something. J is equals to 3 and J plus plus. Oh, what? Thing is wrong. It will give me TLE because I have to add J also here because I want to convert this into 3 or I have to start it from 3. Oh, okay, I will try it from 2, but this is wrong because this will give me 2. And this is what? 2, 3, 4, 5, 6, and 7. 6 is not a prime number. 6 is not a prime. Have we started from 3? Yeah, this has been accepted. What wrong answer? Because of this, I think so. To write, I have to write 2 into I. Wait a moment, 2 into I. And I have to write J plus I. But I will not write here this. Ah, if I write this and this is accepted, and at some point this is wrong. At some point this is wrong, so this will give me wrong answer because I was thinking right. Uh, what's going wrong? Like what's going wrong? Ah. Let me try the simplest way of it. If that will not work, I will. Okay, what I will do here is that remove this. This is C work. What is the first approach? Oh, I will paste the approach. Wait. I'll write it here that okay. If I got the value, if I got n is less than equals to 2, I will return 0. Okay, otherwise what I will do, if I see that okay, this is a prime number, and if this is not a prime number, I will calculate it. So because of this, the time limit has been exceeded. It count plus plus. But if I write this logic, what? Uh, when you start with I is equal to 3, I is equal to return 1, isn't it? Why not check for 2? The will be when you start with. Yeah, I already increment the one. If you see the previous solution, if you see that initially I put count is equals to 1, and when I started from 3 here, what I have to do here is that I have to multiply it with 2, convert it into the odd. Okay, and what I will do here is that I will see that okay, for int I is equals to 0, still I is less than is is prime dot size, and then what I will do here is that I plus equals to 2. And then if I see that is prime, is prime, is prime I. If this is a prime number, then I will increase the count. Then I will increase the count and I will print the count. Now there is a little bit confusion that I will get 7. I will get 7, I don't know how. But if I see, okay, I will increase the count. Uh, I will start it from, I have not, I have to take the jump of plus 2. I know I will get 7, right? So will I have to multiply j with the 2 or I with the 2? I simply add I into it. Oh, it doesn't matter. I got 6 for this. I will start it from 3. I will increase initially the count will be, or will I have to start it from 2 only? For 10, I got 5. And why I got 5? X is prime. Let's see out X. Because I get this. 1, 2, 3, 4, 5, 6. I take a jump of 2. That's why I got 6. So basically what I am doing here is that I will not check for any even or any number that is divisible by 2. I'm only checking for the number that is odd basically. I'm only checking for that number only. So that's why I'm starting from 3. And now what I will do, the next odd number I will get at 5 will be 5. Now what I will do, and then 7 and then what? 9. So, so this loop is correct. Fine. The problem is here, I think so. So what I will know, that for 3, I will start from 9. After taking 9, I have to check that what is the another number. So, so another number will be what? Another number will be g plus I, which is 12. And then I know that 12 is an even number, not, yeah, basically an even number, which is divisible by 2. So I don't have to check for 12. I have to check for 15 directly. So as I want to check for 15 directly, what I will do? I know that, okay, I want the next odd number. As I want the next odd number, so this is what? Uh, this is my odd number, and the next odd number will be, I will take 3. Uh, I will take 3 and multiply it with a 2. So this will give me 6. So 9 plus 6, 15. And then after that, 9 plus, 9 plus 6, 15. So this is fine. I think so. This is also fine because the next odd number that is divisible by 3 will be 15. So I'm checking for 9 and then I'm checking for 15. And after that, what is the next number? So I'm checking for 15. So the next number after that I'm checking for is 21. So I will be 3. So 3 into 2 will be 6 and plus 15 which will be 9, which will be 21. So this loop is also right. And this will tell me that, okay, all of this number is not a prime number. Okay. So will I have to start it from 3? Or will I have to start it from 2? So as I already starting from 2, oh, I only left for that 3 only. So for 3, output will be 2, but I got 1. So 0, 1, 2, 0, 1, 2, 3. Will count will be 0? No. Why or what? So basically, if I starting from index 3, 0, 1, 2, 3. So if I see, I will starting from 3. So I will see, okay, will third index be a prime? Yeah, it is prime because this is 1. So I'll mark the count to be a count plus plus. And what is the previous count? So previous count will be 1. So after adding it, I got the output to be a 2, but expected to be a 1. So the expectation is 1, but I got 2. Because what I know here is that, okay, yeah, this has been accepted finally. Finally, this has been accepted. Okay, so what I actually do here is that I'm only checking for what I know is that, okay, 2 is prime number and every number that is divisible by 2 will never become prime. So I will not check it for that. I will only check it for all the numbers which are odd on it. So that's why I was starting from 3 and all the numbers that is divisible by 3, I will mark this as that, okay, uh, they are not primes because if 3 is a prime, then every number that is divisible by 3 will never become prime. So that's what I built. So I think so. This is fine. Little bit tricky question, but it's fine. It's fine. Mm, fine, 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 fine. Not this, not this. Reclaimed LYP. That's it. That's it. So we have completed this, and let's try to solve this T primes. What is this? Codeforces 230B. Codeforces 230B. Uh, we know that prime numbers are positive integers that have exactly two distinct positive divisors. Yeah. Similarly, we call a positive integer t prime if t has exactly three distinct positive integers. Okay. So you are given an array of n positive integers for each of them determine whether it t prime or not. Okay. So I have to tell that if that number is a t prime. So the t prime is the number which has three distinct divisors. Three distinct divisors. Okay. Hmm. How will I check that if how will I check if the number is prime or not? So if we are using C, then what actually do I know that okay, this is a prime and every number that is divisible by this number is not a prime number. Okay. And what I know that let me think. What I know, so suppose if I want to check from 1 to 10, 1 to 3, 4, 5 is there, 6, 7, 8, 9, and then there is a 10, right? There is a 10. So what I know that, okay, one has never, one never has basically the three divisors, three distinct divisors, right? So this is not a prime, never. This is not a T prime, right? Will 2 ever become T prime? No, because it has one as a one distinct divisor, 2 as another distinct divisor, but I never get any other number which divides 2. So 2 is not become T prime, right? So let's talk about 3. So 3 will also never become T prime because what I know is that, okay, it has two distinct divisors, 1 and 3, but I will never get any number uh, which is basically the third divisor, which divides 3. So if I talk about 4, I know that, okay, 4 has one divisor 1 and another divisor 4. Now, if we are if we are seeing here that if you see carefully that there is one more divisor which divides 4, this is basically 2. Okay, so if I see 4 has basically three distinct divisors. Now, if I talk about 5, 5 has only two divisors. 6 has 1, 6, and 2 and 3. So basically, they have four distinct divisors, but I only want three. Okay, okay. So one thing I understand here is that whatever is the prime, previously, whatever is the prime, they will never become T prime. That's what I understand because I know that 2 has only two distinct divisor, 3 has only two distinct divisor, 5 has only two distinct divisors, 7 is only two distinct divisors. Okay, and same as like 11 and 13. They have only two distinct divisors, so they never become T prime. So first, I was thinking, okay, I will calculate that what all are the basically primes. Okay, so what I have to tell in this question, if I see what is the question. So basically, I have to tell that okay, I have to tell that okay, if this is a this T prime or not, fine. So I can use. Wait a moment, I have to open this. Wait a moment. T prime. T primes dot cv. So what I will do is that uh, control D hashtag include bits slash using namespace std, and I will call a function, and inside that I will implement the sieve of Eratosthenes. So void call, and we have to take multiple inputs, right? So we have n, and what I will do, I will create a vector int nums inside it n comma no n only. Okay, and for auto and I nums c in I. So I have to take the input, and then after that I have to check void, or I will call the function sieve. So this sieve will tell me, okay, whatever the number, if this is a prime or not. So for that I can use a for loop for int x nums, and if t prime, I have to tell that, okay, this number is a t prime or not. If this is a t prime, I will print out cout ts. I will print cout, and then and else what I will do, I will print no here. Now there is another function which is whole t prime, and inside it, or I can what is the input size, or what is n? N is basically, okay, so basically the array size will be 10 is to the power 5, but the element size will be 10 is to the power 12. So I have to take a long. Okay, so I have to take long here, and I also take long x, because I have to check that, okay, this number is t prime or not. So so if this is 10 is to the power 12, if this is 10 is to the power 12, will I create the array of 10 is to the power 12 size for checking if that number is a prime or or a distinct? Okay, so if that number, okay, if that number is 10 is to the power 12, then what is n log n? If n is equals to 10 raised to power 12, what is n log n value? Oh, it will be 39. Huh? What the hell? Base 2 log 2, common in computer science. Algorithm value n log log n in approximately 5 into 10 into 10 raised to the power 12 or 1.8 into 10 raised to the power 12. Or it will take too much time. How I will use C where? Because if x is too much or fx, because I have to know that if this number is a prime or so number. Apply the sieve on this array only. What is the question? Uh, First line showing how many members are in array. The next line shows please do not use LLD specific long double is specified to read or write 64. Hmm. I know that 4 is a T prime, but how will I write it? That 4 is a T prime number. For a single number, I will not do this. I have to create a sieve. I have to create a sieve of this array because I have to tell that while traversing. So I know that the element will be anything. Element will, okay, basically I have to tell that, okay, this number is a prime number or not, or triple prime or T prime. So if this number is T prime or not, how will I know it? If if I see that one is there, two is there, three is there, four is there, five is there, six is there, or any number is there, right? This is not a prime. This is a prime number. This is a prime number. But I am not starting from this point. I am starting from zero. It's T prime, prime square. Factor will be the, if it's prime square. Hmm, what factor will be 1, P and P square. So if I apply sieve there, it has been given in the question that the element has a size of 10 raised to the power 12. So if I apply that sieve in this question, uh, पहले से 10 raised to the power 6 के sieve चेक करना होता है और डायरेक्ट में इम्प्लीमेंटेशन हो जाता है और वाला n log n चल रहा है. So I was thinking that okay, it will take n log n time and it will be approximately equals to 1.85 into 10 raised to power 12 if n is equals to 10 raised to power 12. So maybe it will exceed the time. Maybe it will exceed the time. But let's try. Let's try. So what I will do? What's up, bro? Hello, buddy. Hello. Welcome. Welcome. So maybe I will create a vector long long, vector long long, and inside that I put is prime, and I will write n plus 1 or what? Yeah, I will call this as n comma 1 or not 1. I will mark this as true. Okay, first I will create, or basically I have to write pool here where I will create that much size, and then int I is equals to 0 still not 0. I will write this as 2, and I will go still under root n, and after that I will mark that okay is prime 0 or is prime 1 is equals to false. Okay, and then if I say that okay is prime I uh, is prime, and for loop int I is or not I, it will be j. So j will be started from I into I, and is equals to n, and I will take the jump of I. Okay, and I will mark that okay is prime j is equals to false. This will give me what? This will basically divide all the number. Hmm. Now, one thing I know, what one thing I will do here is, where is xyloid? Okay, this is xyloid. So what I will do that okay, I have to calculate the all the t primes from 1 to 10. So I will write 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. ब्रो आप कोड फोर्सेस से क्वेश्चन प्रैक्टिस करने के लिए कहाँ से उठाते हैं? रैंडम है, यहाँ से, इससे यहाँ से उठा लेता हूँ, इससे मांग लेता हूँ, टॉपिक पढ़ता हूँ, फिर बोल देता हूँ कि भाई क्वेश्चन दे दे, 5 6 दे देता है, कर लेता हूँ, हो गया। और बाकी और प्रैक्टिस करनी हो तो यू कैन यूज द कॉन्टेस्ट, दैट्स इट। Okay, so if I see, okay, I will get 8 and I will get 9 here and the 10 here, right? I will get 10 here. So I know that 1 is not a T prime, 2 is also not a T prime. So I will mark this, and 3 is also not a T prime. So every number that is less than 3 will not be a T prime. So for 4, so what I will do? I will mark. Okay, I have to mark. How will I mark? So I will see, okay, suppose if I see, so suppose if I see 2 here, I know that 2 is not a T prime. So what is the factor of 2? The factor of 2 will be 4. So 4 will be T prime because it has three distinct factors. Okay, three distinct factors. So I will mark that, okay, 4 will be basically what? I will mark this to be a false, but basically I have to mark this to be a true. Okay, I will mark this to be a true that all the factors like 4 will be a T prime now. Uh, and initially, yeah, I will mark this, okay, 0 and 1 are not a T prime numbers. Hmm, ठीक है. So I will see 4 is there a T prime and then I will jump to 6. Will 6 be a T prime? So I will see, okay, what all are the factors of 6. So it will be 2, 3, and 6 here, right? So initially I will mark this, okay, this is not a T prime number. 2 is also not a T prime. 3 is also not a T prime, but 4 is there. This is a T prime. And mm, I will tell that, okay, 4 is the first T prime number. So all the fact. So what is the factor of 8? So basically 1 is there, 2 is there, 4 is there, 8 is there. 8 is there. So this is not a T prime. Will 5 be a T prime? No. Every prime number is never become a T prime. So I will first, what I will do, I will tell that, okay, this all are my prime numbers. And now I will convert it into, so I will write 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is not a prime number. So this is false. This is a prime number true. This is a prime number true. This is false. This is true. This is false. This is true. This is false. This is false. And this is false. Right. So every prime number will never become T prime because prime number is only two factors. So I will see whatever the prime numbers are there. Now they will never become T prime. One thing for sure. So I will know that, okay, this should be false, this should be false, this should be false, and this should be false. Now, one thing I also know that 1 is never become a T prime or 0 will also never become a T prime because they have never have a three distinct factors. So I'll mark this as false. Now I will start it with 4. What is what all are the factors of 4? So I will see that, okay, the factors of 4 will be 1, 2, and 4, right? So they have three distinct prime factors or three distinct factors, right? Three distinct factors. So 4 will be my first T prime. 4 will be my first T prime. All primes are square. All prime number square is T prime. All prime number square is basically a T prime. Okay. I was observing. I will check. So I know that, okay, will 6 be a T prime? So 6 will never become a T prime. Because why? Because they have 1, 2, 3, 6. They have four distinct vectors. So this is not. Okay. So after that, I'm seeing 8. Will 8 become distinct T prime? No. 1, 2, 4 is there, 8 is there. So this is also not a T prime. So this is false. So after that, I will see 9 here. So 9 have 1, 3, and 9. Okay. So I will see, okay, 9 is T prime. So if I observe carefully, I will see that if I pick the prime numbers, okay, if I pick the prime numbers and the square of that prime number will be what we call the square of that prime number will become t prime. So that's what I was observing. Now I have to check that, okay, uh, will I pre-compute or will I do something? So what I will do, I know that, okay, this is a prime. So one thing I know here is that, okay, if I get a number and if this is less than equals to 3, I have to write that or tell that, okay, see out, not see out, I have to return false if this is not a T prime. Okay, now next thing what I have to do is that I will see, okay, this is a prime number, and if this is a prime number, then square of that number. So for 2, 4 will be a prime. Uh, for 2, 4 will be a prime. So how will I mark it? But okay, so I will see that, okay, this is a prime. If I use another loop, what I will do, I will start from the 0 and go still what? Go still I is less than is is prime prime dot size. Okay, if I see this and if I see that, okay, if this is a prime number, then this is a prime number, then what I have to do here is that every prime number is not a T prime. So I will mark that, okay, is prime I is equals to false. I'll mark this to be a false and is prime I is prime I. Wait, so this is an array, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, this is 10. So this is initially false. This will be false. Okay, this is true. This is true. This is false. This is true. This is false. This is true. This is false. This is false. And this is false. So when I'm here, what is this? Index will be 2. So I will be 2, right? I will be 2. So I will tell that, okay, mark this I will be a false and multiply this or square this value. Okay, so after squaring, I got 4. So what I have to do? I multiply I. I multiply I. I do I multiply I. Tell that, okay, this will be a long value. Now, what's the problem? Problem is that I know that n will be up to 10 is to power 12. So if I is equals to 10 is to power 12, and I multiply it with I, it will become 10 is to the power 24 and it will never store anywhere. So I got either a TLE or a compilation error or a runtime error. Okay. Hmm. Now, let's see if this number is a prime number. If I see, okay, this number is a prime number, every number that is divisible by this will never become prime. Uh, if I see if this is a prime number, what I will tell that, okay, uh, and now what I know, if I see that uh, J by I, if this is equals to I, if this is equals to I will mark this as true, that okay, this is tree prime. And one thing I also mark is that is prime I is equals to false. Okay, and else what I will do for any other number, I will mark that okay, J is false. So let's try if this code will work or not, I don't know. Every time I will call this function, what's the real problem is that every time this loop will run. So basically, this will run n log n time, n log n time, and this will run n times. So n square log n. So that's the complexity of this. N square log n. What I will do, this will return me either a true or a false. So how it will return me true or a false? So it will return me like this. I will return is prime for whatever the n has been given. So this will tell me if this is a prime or not, t prime or not. Control B. Mm, so it will give me for 5, it will give me yes. Why? I have to print. for int x is prime. For 4, the size will be 5. For 4, the size will be 5. 0 is not a T prime, 1 is not a T prime, 2 is not a T prime. So I know that till I have to start it from 4 now. Yes, yes, yes. I got yes, yes for everything. Like why I got yes for everything. I tried to. What I will do here is that I will see a 0 is not a prime number, 1 is not a prime number, 2 is a prime number. 2 is a prime number. So basically, I don't have to check for this. I know that 2 is not a 2 is a prime number. So as 2 is a prime number, then what I will do for 4, for 4, I am only checking till 2. For 4, I am only checking till 2, right? I want to know that 4 is prime or not. I will create the array of 4 size and of 5 size. I will tell that, okay, look, what's going on? I'm creating array of 5 size. So 0 is not prime, 1 is not prime, but 2 is prime. So as 2 is prime, I will mark that, okay, if 2 is prime, I will mark it that 2 is not a T prime. So I will mark it as false. And I will see what is J. So if I see that, okay, uh, if I will write I into I, then I will only do this. Yes, yes, no. I will see, okay, 2 is prime. Basically, 2 is prime, so I will mark this as okay. Whatever the element that is present, I will mark this as false. And I will tell that, okay, this is basically a T prime. So 4 is a T prime, right? Uh, but what's the real problem is that I will never check it for 2 or not 2. I will never check it for 3. I will never check it for 3 because I am stopped at that specific point. How will it check it for 3? Don't have to do anything here. I think so. What I understand is that, okay, mark this as, let me see what I got. Okay, I will got, okay, these are basically primes, fine. And now if I copy this, I is equals to 0 still, I is less than is prime dot size. I go till that point, and if I say, okay, this is a prime number, if this is a prime number, what I will do is that, okay, mark this is prime I to be a false because this is not a T prime, and is prime I into I to be a true. Okay, mark this to be a true. No, 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 not from, I will start it from 3. I will start it from 2 only. Everything will be 0. Why? Like for 2, if I see, okay, 2 is prime, so I will mark this as, okay, this is not a prime number. And I into I is equals to true. I will mark this as true that, okay, this is a prime. So, basically a T prime. So I got 0, 0, 0 everywhere. I will see 2 is there. And I know that, okay, uh, what I know is, okay, 2 is a prime number. So the square of 2 will never become a prime. Uh, but square of 2 will become a T prime. So I'll mark that, okay, if this is a prime, and I will mark this, okay, this is false. This is not T prime here. And I into I will become T prime. This will give me 0, 0, 0. I don't know why. Hmm. So this is fine. But when I am iterating over this, I will see, okay, this is a prime number. So square of this will be square of this index means 0, 1, 2, and this is 3, this is 4. I will mark this as, okay, this will be true. but it will never become true. It will never become true. It becomes zero. It becomes zero. Don't understand why this will happen. Why this is not. What is? I will think it tomorrow.